So we're looking at bending of a cyclist. See, basically when we are going on a circular path, so we saw that car, it had friction that helped it go in a circular path. If not, we can have the road bend that can help it, along with the friction that can help it go faster around a circular path. Now, if a cyclist has to take a circular path, say a flat road, right? We're looking at flat road. If the cyclist has to take a circular path, the cyclist has to bend. They bend. I mean, you guys would have done this, right? We bend basically, is it not? When we are taking, so why not just use, friction? The friction is so small that it doesn't work out. Okay, so the friction is so small that it will help, but not to that extent. What really helps is the bending. So the aim over here is the aim of the cyclist bending or leaning while describing a curved path is to ensure that the net force acting on the system points towards the center of the circle, and so we have the centripetal acceleration that is needed to centripetal force, and thus the acceleration that keeps the cyclist and the bicycle moving in a circular path instead of sliding tangentially, instead of going straight. So that's what we are trying to figure out. So for a given amount of bending, or what bending should we have to achieve a circular path, and how much velocity and all of that. So we are trying to figure that out. Okay, so we are basically looking at this bending. Okay, the R bending with respect to the road. So you can imagine a straight line going through us. So that bending. Of course, it's not as simple as that, but yeah, we are going with it. So now, as a result, what happens is it will be as if we are taking a, yes, we are moving along a bent road. I mean, what is this? Bank road. Sorry, yeah, bank road. So we have mg, and your reaction force is what is making this possible. So we have R, right? That bent is because of the reaction force. We have tilted ourselves in this way, and that's it. There's nothing else. So we need to resolve this along the horizontal and along the vertical. Okay, so it's a bit longer than, I can change this actually. Anyways, we'll continue. So if this is okay, if I happen to draw it over here angle wise, this is theta. I explained in last video why is this theta. It's quite simple actually. So these are the only set of forces which are helping us over here. So if I take up and left as positive, and this is our scenario. Now, if K is approximately taken as 0 Newton, right, as force of friction, this is for our understanding, between tires and the road is too small to provide. It is there, not that it's not there, but what we need at the speed that, oh yeah, okay, before this actually, please pause, go and search for cyclist, race and all of that. So you have motorcycle race, car race, and so cycle race, right? Web search that, look at the speed at which they travel, and look at their bending and all of that. It'll give you guys a good feel. This does not. I just wanted to give an idea, so I have this. But yeah, you should get a feel of that, then this you'll appreciate. Okay, I hope you guys did that, as in going online searching for a race with cycle, decathlon, triathlon, Ironman. Not that Ironman movie I'm talking about. Yeah. So first thing is always get an expression for vertical scenarios. So along the vertical, so we have r cos theta minus mg should be equal to 0 because the cycle is not going upar niche. So we have r cos theta is equal to mg. Then we have along horizontal. Again guys, just write what is obvious, don't think too much. R sin theta provides all the necessary. Yes. Okay, so we're accelerating here, so it is equal to this particular expression, and this I can further write it as v square by r. We are trying to figure out vc expression, so I'll call this as 1 and 2, and now we have to divide 2 by 1, and so okay, I can do this. R first will be LHS. No, I'll take m vc square by r. It's getting divided with mg is equal to r sin theta divided by r cos theta. I think I didn't miss anything. Oh, sorry, we are not getting value for vc. We want to fix v, v, as in I want to go at that speed. What is the amount of bending I'm looking at? That's what we are looking at, So tan theta, this is the expression we are looking at, vc square by rg. So I want to speed, curve, take this curve with this speed. What is the banking I need to have? This will be the expression the experts will give. That's it. They'll plug in how much velocity you want and what is the radius of the bend, right? What is the radius of the, like say there's a curve. So they'll extend this curve as an imaginary circle. They'll figure out the center. So they'll tell you the radius, gravity over there, and the velocity that you desire, that you will tell. And they'll tell what you need to bend so much, so that you don't skid. Okay. So that would be it. So that's how the bending works over here. Again, with the math, it's so simple. It's so simple to understand. So you need to understand that all this is a language for us to understand the universe. Right? So appreciate that. Okay, watch, experience what we're learning over here. Only then you will enjoy this. If not, no point.